During the final decades of the 1800s, workshops throughout the global industry introduced mechanical behemoths, which made the personnel supervising them look minuscule. Once fully built, these massive edifices rose many levels high and possessed a mass of hundreds of tons, possessing the capacity to manipulate liquid iron with an accuracy that seemed inconceivable for their magnitude. Upon impact, they discharged against the base with such intensity that nearby workers felt their very teeth vibrate and their sight dim. This is the chronicle of the steam hammer leviathans, apparatuses that balanced on the thin boundary of creation and ruin with every deliberate strike. Having observed the perils a steam hammer presents, let us explore the origins and logic of its creation. It was in November 1837. Maritime builders and motor producers sought components so massive that conventional smithing techniques were unable to cope. A particular commission seemed virtually unattainable. Isambard Kingdom Brunel, the British structural and mechanical mastermind, widely viewed as one of the most creative and productive individuals in the annals of engineering, called for a novel paddle shaft, spanning roughly 30 inches for his latest ocean-going vessel, the SS Great Britain. The difficulty lay in the fact that this exceeded the limits of any contemporary smithy. Enter James Nasmyth, a straightforward Scots engineer, who took on the task and provided a functional blueprint. He drafted an uncomplicated remedy: hang a vapor cylinder directly above an anvil, link the striking mass to the piston rod, then employ steam to raise it before dropping it vertically. The objective was a straightforward, regulated crash-delivered plumb, as opposed to a mechanism that pivoted like an extremity. Technicians would eventually liken it to a steam motor, suspended from its own chamber, designed to exert force in a strictly vertical plane, whilst devoid of any turning function. Across the English Channel, François Borden and the Schneider works at Le Creusot shared this requirement and constructed the inaugural operational prototype. I should also mention a detail at this point regarding an enduring controversy. Whilst Bourdon crafted the first physical working model, it is alleged by Nasmyth that it was fashioned from a duplicate of his plans. As the old adage goes, the more things evolve, the more they remain unchanged. Regardless, that apparatus had a mass of roughly 2,500 kilograms, exceeding 5,500 pounds, validating that the theory was effective outside of mere sketches. In later years, the grandest hammer supports towered as massive A-frame iron structures, and viewers likened their profiles to that of the Eiffel Tower. This was not intended as a copy, but rather a tribute to magnitude and technical skill. It was a metal construction vast enough to serve as a beacon. Now, I am unsure about your feelings, but this variety of industrial aesthetics is something I truly find magnificent. So if you share my fascination with these accounts of industrial heritage, it would be greatly appreciated if you could subscribe and share your thoughts in the section below on which industrial mishaps I ought to examine next. Very well. Let us return to the narrative. The laborers characterized the gargantuan steam hammer as a harnessed energy, subject to the exact desires of the valve controller. In 1878, observers at Le Creusot viewed a steam hammer so immense that it was mounted on an anvil base, totaling roughly 750 tons. I shall state that once more, 750 tons. And here is the detail I find most compelling. The staff remarked it could descend so subtly that it might seat a cork in a bottle without a fracture, yet immediately pulverize a white-hot block of steel thereafter, as though it were nothing more than malleable silt. It was a fine equilibrium that hinged on the factory's cadence. The team shifted heated iron into position using grippers, and every phase was contingent on the ascent, the hesitation, and the fall, all occurring precisely when anticipated. It was the sort of coordination that only develops from decades, working alongside one another. Envision a football squad that has collaborated for so long that every member simply senses where his peers will be situated, practically without a glance. It is an intuition that cannot be instructed. That is how Nuhm crews handled radiant metal in flawless cadence, relying on each other's synchronization and reflexes. The output of these forges was far from minor. It constituted the massive structural foundation of industry, immense axles for locomotives, heavy components for vessels, and elements for protective plating and weaponry. These requirements were the reason the hammer saw such heavy use, and why error was not a permissible outcome. The difficulty was that the machinery was dependent entirely on vapor, force, and cues. If a person was a fraction of a second tardy, if the workpiece was positioned unevenly, or a gripper slipped by chance, the delicate caress of the Titan hammer, well, that fame vanished, and brutal power took command. Certain of these facilities processed metal blocks up to 120 tons, and when such a mass moves abruptly during a strike, it could leap, rotate, or even discharge fragments. One tidy blow could result in a flawless component. However, conversely, the equipment could launch jagged metal into the atmosphere without notice. This explains why veteran teams held such awe for the machinery's vigor. They recognized it could be soft-handed when necessary, but solely if every detail was perfectly aligned. The instant that vigilance faltered, its raw capability emerged, and rarely in a manner that anyone desired. Regarding sheer force, I considered it quite amusing to witness the outcome. Should one of our routine possessions be flattened by one of these vapor-driven hammers? So let us take a brief interval to observe its effect on a watermelon. And indeed, this footage was produced by artificial intelligence. Regrettably, I lack access to a 750-ton vapor hammer myself. Haha. Now that is the sort of thing that restores my youthful wonder. Continue watching until the conclusion for further objects being demolished. Contrary to popular assumption, the hammer's impact itself was not always the primary hazard in many incidents. It was the actual transit to reach the base. In 1915, a plant observer noted that the vapor hammer's head sat merely a few inches from the deck, and that the gravest danger was situated near the floor. Embers and metal shards consistently fired outward like a firearm, and the peril zone remained within about 2 feet of the surface. Consequently, to operate in that area, men shielded themselves as if they were entering a combat theater. Shinglers donned heavy metal reinforced boots reaching above the knee, alongside a metal mesh covering their countenances, since the ground level was where accidents occurred most frequently. Yet then again, I have viewed numerous images, like this particular one, and film recordings demonstrating the exact opposite, with laborers possessing virtually no safety gear whatsoever. So what is your view? Were we merely reckless in that era? Or do you believe it was simply an age of uncompromising masculinity? Inform me in the comments section. I would be keen to hear your perspectives. Regardless, safety gear did not address the broader issue of stability. The most taxing portion of the role was the sprint from the kiln to the hammer and back. The blistering hot burdens could not be put down, not even for a brief moment. If the trolley struck a stray metal fragment or an uneven floor surface, it might capsize. And if a laborer tripped once, the cargo could tumble off and shower down upon them. In one gruesome incident, a youth tripped on the deck while dragging a massive, radiant mass towards the hammer. The handcart overturned and the heap fell onto his midriff. The bystanders extracted it swiftly, but he passed away a day or two later. And the most galling aspect was the method of payment for this toil. Compensation was based on tonnage, rather than time. So the more metal they processed, the higher their wages. Inevitably, that variety of arrangement spurred the men to work with haste, no matter the level of danger involved. And as we are all aware by this stage, that is invariably when mishaps occur. But it only becomes more dire, as that was not the sole peril encountered by those working near the vapor hammers. At the dawn of the 20th century, the grandest forging plants functioned like indoor marshalling yards, with hoists traversing along overhead supports, and massive grapples oscillating above their heads. A steam hammer may have been the focal point, but the cranes and linkages provided its sustenance. They were tasked with transporting the molten steel and iron from the kiln to the anvil, in slow, groaning paths. Every ascent was dependent on mass and trajectory. The tackles suffered from the vibration, the warmth, and the grit. Occasionally, a link appeared sound, but then suddenly it elongated, snapped, and failed. And once a chain began to yield, Teams possessed only mere seconds to escape. They scrambled away, they shouted alarms, and attempted to ensure the cargo landed as intended. Because a falling workpiece did not recoil, it obliterated. Can you conceive of standing there minding your own affairs, yet also becoming distracted by your thoughts, averting your gaze from the task, when abruptly, a vast torrent of liquid hot metal descends either immediately beside you, or more catastrophically, directly upon you? It strikes me as ironic how individuals in comfortable administrative roles today lament having a difficult day at the office. Context is paramount if you truly ponder it. Consequently, in the United States, constructors kept striving for larger impacts, and Bethlehem's Grand Vapor Hammer was reputed to produce a 125-ton blow. I still find it hard to comprehend that level of energy. To exert a magnitude of force at that scale meant the components were gargantuan, and transporting them securely was as vital as their fabrication. Yet as experience demonstrates, nothing is permanent. Bethlehem Steel constructed a near-exact replica of the Le Creusot hammer in 1891, then demolished it in 1902. A rapid ascent, and a sudden conclusion that illustrated how ruthless the competition for scale could be. Very well. Let us pause for another brief divertissement. On this occasion, let us witness the potential outcome of a bowling ball being pulverized. That provided quite a sense of gratification, yet the subsequent demonstration may prove to be my preferred viewing. So remain tuned to discover if you share my opinion. By 1902, certain American foundries had already realized the most perilous breakdown wasn't invariably the hammerhead, but the apparatus beneath it. A forging die could withstand thousands of impacts, recurrent thermal cycles, and incessant abrasive dust, which might induce a minute fissure to propagate through the steel. When a workshop fell behind its schedule, degraded dies occasionally remained in operation longer than advisable. The difficulty was evaluating a facade that appeared robust, while internal tension continued to escalate within it. The laborers would hearken for any alterations in resonance, and observe for any shifting in the workpiece. They had to remain conscious that the following strike might be the definitive one to cleave the die. Consequently, when a die shattered, the hammer persisted in its function. It continued its descent, and the pent-up power sought an exit, and it could catapult keen splinters across the workshop floor, transforming the vicinity of the anvil into an instantaneous danger zone. Men scrambled behind columns or brandished heavy pincers for safety, but the debris moved with greater speed than any human reflex. It resembled a popcorn kernel combusting, save for the discharge of razor-edged steel bits instead of treats. I am aware that was a rather trite quip. Some of the grandest steam hammers functioned for 52 years before decommission. Such an extensive operational life meant degradation was perpetually gathering in the background. A rupture could stem from defective metal, negligent upkeep, or simple misfortune, and the precise catalyst was never entirely evident. All it required was one further solid strike for that unit to hurl shrapnel. Now that we grasp how vital it was to preserve the machinery within the plant, let us shift our focus to a different segment of the narrative that you might find quite startling. The true core of the hammer's peril lay not merely in its metal or vapor. It resided in the manual control and the discretion of the operative. Every individual blow was contingent upon concentration, proficiency, and rapid-fire determinations. We must not overlook the human factor in all of this. In the late 1880s, certain massive hammers were steered from a dais, integrated into one pillar of the structure, situated aloft alongside the reciprocating work on apparatuses like the Great Hammer at Le Creusot. The pillars reached over 30 feet in height, and the controller peered from that elevation as the staff labored below. He manipulated a valve, sensed the machinery's rhythm, and interpreted the team's gestures through mists of fumes and embers. Vapor pressure could hit a mean of roughly 71 pounds per square inches, and that invisible energy meant the hammer could ascend once more, the moment he triggered the valve. Frequently, blunders did not appear spectacular. A strike might land marginally off balance. A workpiece might tumble rather than coming to rest. A laborer's fatigued hands might relinquish their hold on the grips, resulting in them sliding or rotating. The issue as you might anticipate, is that in a facility of such volume, even the most intense vocal cautionary cry might never reach the controller's dais. The result relied entirely on the operative's background. Using the identical handle, a gifted controller could temper a blow, retard the sequence, or suspend the ram aloft long enough for a man's limbs to retreat. That explains why veteran hammermen approached the task with such reverence. Governance relied on human synchronicity, and as we are aware, people are liable to err. As the legendary John Henry remarked to his superior, "A man is merely a mortal man, but before I permit my steam drill to best me, I shall perish with a hammer in my grasp, Lord. Lord, I shall perish with a hammer in my grasp." By March 1918, certain American foundries were shaping 1/4-inch projectiles under vapor, hammers to fulfill military requisitions, which permitted little space for injured hands or aching backs. The tasks arrived searing, weighty, and rapid, and teams had to keep pace to ensure output remained constant. Produce or perish, as the saying goes. Even outside of work, these hammer squads were identifiable within the community. Many appeared lanky and slender, possessing ashen complexions and dark shadows beneath their eyes. At the conclusion of a rotation, grime enveloped them, and some carried it like a symbol of distinction, maintaining flawless timing under incessant warmth. Clamor and strain was arduous. Satisfaction and resolve can only sustain a person so far. As Morgan Freeman observed in The Shawshank Redemption, every individual possesses a limit. When plant owners clamored for accelerated output, the minor errors began to accumulate. It might involve a rapid movement into a narrow gap, just a solitary extra lift, or a die that required a further inspection. A frightening incident could arise from numerous origins: an administrative push forcing a team into understaffing, an individual or a laborer striving to demonstrate his endurance, the characteristic audacity that we men pride ourselves upon. And lamentably, these varieties of blunders are not merely historical, they persist in occurring even within contemporary forges. For instance, in 2012 at Carlton Forge Works in Paramount, California, an operative was managing an 800-ton hydraulic gravity hammer. Whilst performing a forging task, a segment of titanium piping sat beneath the apparatus. When the energy descended and a component in the arrangement failed, a piece of the piping fractured and transformed into a missile. It impacted the laborer, and he perished on the spot, illustrating that even labor that seems restricted can turn into airborne steel in a heartbeat. From what was discernible in the aftermath, the precise origin was not apparent. It might have involved the manner in which the pipe was secured, the choice of hardware, a shift in centering, or structural failure. Under recurrent heavy operation, a plant can function for years without that outcome, until a single impact identifies the vulnerability. This is why veteran forging teams scrutinized the arrangement. As intensely as the hammer's surface, they grasped that the peril was not merely when it descended vertically, but what might slide, detach, and move laterally with the intensity of the blow. Very well. Let us ease the mood with another destruction interval. What say you? Ever pondered the result when a bulky Converse vintage television goes head-to-head with a vapor hammer? Well, fortunate you are about to discover the answer. Right then, all you eccentrics out there, do not entertain any notions of attempting this at home. Leave the demolition to the specialists and remain with us, as there is one final unexpected smash awaiting you at the conclusion of the recording. Right. Let us proceed. So I might inform you of one final concealed hazard regarding vapor hammers, and as you might have surmised, it is contained within the name of the Colossus itself. In 1850, a standard primary engine was often calibrated at roughly 30 pounds of vapor pressure per square inch. Over the succeeding decades, many workshops increased that towards 80. What did that imply? Well, elevated pressure signified more labor, accelerated rates, and superior gains, yet it also heightened the peril in conduits, couplings, and regulators. In numerous locations, there was no uniform manual, and the facility supervisors often relied on intuition to establish what was tolerable. A vapor system contained vast quantities of invisible energy. Should a valve seize, a seal fail, or a pipe fracture. Pressurized vapor could burst out instantly. It could inflict severe scalds in moments, obstruct breathing, and rapidly saturate the shop with dense mist, obscuring other hazards from sight. In a clamorous forge, it might take several seconds, or even more, to even identify the noise and grasp what was occurring. In other cases, upkeep was postponed because it was too costly. And if you have observed our previous recordings, you will recall this was prevalent across all sectors and eras. Revenue over safety every single wretched time. People began to view the hammer as more than a mere implement. It quite literally became a feature of the workshop. In 1877, the great hammer at Le Creusot ascended within, its metal frame high enough to resemble an internal tower. And as I mentioned previously, the likeness to the Eiffel Tower's silhouette made the iron construction feel like a shrine, as much as a machine. The magnitude reached beyond the hammer itself. 4 swan neck hoists shifted iron and steel into position, and 6 Bessemer converters supplied the site with steel, as if the hammer relied on an entire ecosystem functioning around it. Beneath the hammer, the base was constructed to endure punishment. Massive blocks, timber foundations, and deep stonework were meant to absorb the shock. Yet tremors still migrated up wooden pillars and rafters. In Bethlehem, and mills of that ilk, the hammer was a plant's prize asset, continually urged to accelerate as requirements expanded. Every new vessel or motor was another cycle, and the proprietors kept funding more robust hammers to conclude the task before time expired. Yet all that advancement arrived with a toll. The same hammer that imbued laborers with pride also kept them, toiling through incessant clamor, warmth, and strain, day after day. Do you know of anyone who toiled in a vintage plant like these? If so, could you do me a kindness and share in the comments? I would be keen to hear those accounts. I am perpetually intrigued by conversing with my seniors and sharing their narratives in these vocational settings. Ultimately, the renowned Le Creusot vapor hammer was decommissioned after decades of service in 1930, and the justification was easy to state but difficult to acknowledge. Novel machinery was usurping its place, in the form of hydraulic and mechanical pressing units. These apparatuses could exert a more uniform energy, while diminishing the concealed structural defects. Within a forging, the Le Creusot hammer's foundation reached stone about 11 meters down. It was constructed to resist impact, which indicates the amount of ferocity the constructors anticipated. The structure had to be moored that deep simply to endure the labor. What likelihood did a man's frame truly possess on the deck above it? And thus the vapor hammer became a token instead of a tool, a monument to the era when iron dominated, and men compared their own strength against it. In 1969, it was dismantled and reconstructed in the Municipal Plaza, and in 1981, the ASME classified it as a historic site. It left behind dignity, earnings, blemishes, and a caution that internal energy perpetually demands payment, even when the reckoning arrives late. Gratitude once more for viewing, but now for our grand climax. Observe as the vapor hammer disposes of that ornate porcelain that your wife or your partner pledged you would never employ. It is time to create some space in the sideboard.